But let me start by telling you a story. In the beginning, everything was chaos and was proprietary. No open source, companies own all of the formats we used back in the 80s. No standard ruled the network until ASN1 appeared back in '84 when I was born. More standards became popular. Sun Microsystems, rest in peace, developed XDR for Sun RPC. That was back in '87. And then the revolution we know as the World Wide Web started. The www was born and it became available to the public. And with it, our best friend, XML. In need of a web-friendly RPC protocols, they came up with XML RPC. And with it, when it became a standard, they named it SOAP. For some people, it might bring bad memories, or some others might love SOAP, why not? And then everything was chaos again, a widely used chaos. In need of a better and more intuitive web, we came up with REST. Now it's a better way to communicate between HTTP protocols, and following it, our favorite format to transfer information, JSON. And JSON became the queen. And it still is until today. Who uses JSON for its APIs? Pretty much everybody. Nice. But there is, of course, life beyond JSON. So we are going to explore the protocols and binary formats that are available, especially in Node.js. My name is Julian Duque. I'm a principal developer advocate at Salesforce. I'm a Node.js developer. I've been contributing to the Node.js project for a while. And this is what I breathe, pretty much, JavaScript and Node.js. So I'm going to be talking about this topic, encoding and decoding data, or serialization or deserialization using JavaScript libraries. We mainly use encoding and decoding in these three specific areas. Databases, so what are the format representations of the data that I am putting into a database? Networking, what is the format of data that I'm using while sending data through the network, like API communication, and message passing. If I am using any message queue, Kafka, RabbitMQ, what is the format of that data that is going through the net in this event-driven system? So, of course, if we want to explore the binary formats, we need to talk about JSON first, because this is going to be our baseline, the format that we are going to be using to compare to the others. So you might be familiar with JSON. This is the JavaScript object notation. This format is text-based, so you are going to write and read this format using like a text reader or writer. Normally, it doesn't have a schema, so it doesn't have a format of the data that I'm going to be sending. It is considered schema-less. But you can also add schema support through either JSON schema or OpenAPI as well. It's another standard that you can use to give a shape of the JSON that you are going to use on an API. It is highly supported. Pretty much we can say that it is web native. Any browser knows how to read and write JSON. And it is widely used both in REST APIs, now with GraphQL, like the main data format that we use in GraphQL is going to be JSON, JSON RPC, and many more. So JSON, as I mentioned before, is the queen. But we have some advantages and disadvantages with it. Here I have a JSON structure, as you can see, from my attire and the information that is on the screen. I love role-playing games and fantasy games. So I have a representation of a Dungeons and Dragons character. I have my name, who is playing that character, the profession, what species am I, and I have some attributes, some proficiencies. So I'm using some data structures to represent this data. Here we are seeing strings, booleans, numbers. We are seeing objects as part of the same JSON structure, and an array with multiple values. So we are going to be representing this data exactly as is with other formats. So let's explore. For me are the main three binary formats to represent data that are going to be widely used right now. So let's talk about those binary serialization formats. We are going to cover message pack, we are going to use proto-buffers, and we are going to cover also abro. Who has used any of those three? Okay, I see some hands, nice. So for those that have not used this information may be very interesting for you all. So let's just start with message pack. Message pack is, we can consider it like the most closer to JSON. It is a JSON alternative. It is also schema-less. You don't need to specify a schema or a shape of the structure. You can encode and decode any data that you want to pass to this format. The result is smaller than JSON. So any data that you are going to be encoding with message pack is going to result in a smaller payload. But what are the caveats? It is not human readable. If you open a message pack file, and we will do so later, you might not understand what's going on. This is meant for machines. Machines are going to be able to read and process this information. It is also supported by over 50 programming languages and environments. So it has a lot of different libraries out there. So if you are not a JavaScript developer for a Java, Lua, Ruby, or whatever, you are going to have also support for message pack. In Node.js, we will be using the message pack package. It's a library that you install on your computer, and that's the one that you will be able to encode and decode message pack files. This is a JavaScript implementation of it, but you can use different ones. One thing to note is, even though message pack is going to give me a way more smaller payload, Node.js and JavaScript is way faster while encoding and decoding JSON. So even though we have a smaller payload here, we cannot go over the performance that JavaScript can do pretty well, because JSON is native in the JavaScript ecosystem. And there is like an image from the message pack website. Pretty much we have a JSON structure, and what we are doing is that certain characters, we are encoding those characters as hexadecimal, as binaries. Instead of sending the whole string, we are just compressing the information a little bit. Then when we are decoding, I can understand, okay, the next couple of bytes are a string, so I'm going to be processing that information as a string, and this other information is also Boolean, so I know how to read without passing the full string. How can we use this on a JavaScript file? I have these examples, and I'm going to be sharing a GitHub repository with those for you to play with. So I am requiring that message pack library, both the encode and decode methods. I am importing that character.json structure that you saw at the beginning, so we are going to be playing with that one. And then what we can do is encode that information. So we are going to create a message pack buffer, and we compare that message pack buffer is equal to the decoding version of that message pack buffer. We are doing some other stuff, like comparing the size, making sure that obviously message pack is going to be smaller than JSON, and we will see the example later at the end when we run some benchmarks. Now let's talk about protocol buffers. So protocol buffers were created by Google. Protocol buffers are schema-based. This means that we will need to create a file or something that describes how this information looks like. So I will need to define, these are my fields, and these are the data types of my fields. Protocol buffers are super fast, and the information I am encoding with this is also small. It has support for code generation. So I can read a protocol buffer description, and I can come up with a client to connect automatically to this server, for example. I don't need to write the whole code by myself. So this is bringing me memories of SOAP with the WSDL or the Whistle when I needed to create like a client to communicate with SOAP. It's becoming similar, so we are coming on a cycle, but with more performant technology. And it can define a protocol for RPC. And we will mention the protocol that it uses that was also created by Google and it is now widely used, which is gRPC. Here we have an example of a protocol buffer character representation. I have this message. I am defining my object as a message. That's how it's called, because we are defining a protocol to send information. I am defining an object, which is the attribute. Remember that we have like an array of multiple attributes. So I will define the attribute as those fields that are integers of 32 bits. So we have way more data types to represent information. Instead of using the dynamic form that JSON has, we have more specific data types. And then I'm defining the other ones that belongs to my character. As you can see, attributes is of type attributes, so I can have like nested objects as well. Those numbers that you can see right next to the name of the property, it means the order of the fields. So when I am decoding the information, I know in which order they are, so I can perform a mapping. So protocol buffers, what they do is they don't send the name of the properties as part of the payload. They just send the data. Message pack needs to send the name of the properties. JSON needs to send the name of the properties. But protocol buffers, they just set an order. So if I'm getting something on the location number 3, I know that is a profession. This is why I need a schema. So both the server and the client need to know the schema. This is very, very important for this protocol. Example, I am requiring the protobuf.js library. I am requiring the character. I need to load that schema file. I need to load that character type or message, and then I can verify that the data that I want to encode is valid for that specific schema. If I don't have the same properties, or if I have like different information, it will throw an error. If we don't have any error, I will be able to create a message and encode it. So I'm going to get a buffer, binary information. I can compare that binary information with the original one, and then I can decode that information and get the original object. So I can create, encode it, or decode the object as well. Now, this is my favorite, and you will see why. It's called Agro. Who has used Agro before, or has heard about Agro? Okay, cool. Nice. So Agro, it is an open source project by the Apache Foundation. It started as part of Hadoop, which is a distributed data service. Agro, it is also schema-based, so you will need to specify a schema to how we are going to be representing the information. And this schema can be either represented as JSON. You know, JSON is still clean. We are going to be using JSON. Or dynamic language that Agro has. So here, what we have on the right is the same pretty much character that we specify with protocol buffers, but with Abro. Abro is super fast and it's also small. And we will see on our benchmarks that in some cases it's going to be smaller and faster than protocol buffers. It also has an RPC protocol, so you can create an Abro server for remote procedure calls. And as you can see here, for this protocol, you are not specifying an order. You are just naming the properties with the specific type, and that's it. The algorithm is smart enough to get that information back and decode the data. So with Abro, we can use this library, AVSC. We get the character. That's the JSON data we are going to be encoding. We just get the type for that specific schema. So we are getting the character type of the schema we just read. And we are going to convert it into a buffer. This is the encoding. Or we can get the value from a buffer. And what we are doing here is the decoding. So you can see that both operations are coming from the type that I am getting from the schema. So now the type knows all of the properties needed to encode and decode the data. And then I can check that effectively my character is of that type. So I have the isValid method on the type object. So let's see the three different areas where we are going to be using these data formats: databases, networking, and message passing. So in databases, message pack is widely supported by Redis. So if you are working with Redis key value store, the Redis Lua, the language that Redis uses internally for scripting, has native message pack support. And when you're using Redis as cache, since we want to store smaller objects in our cache, you can use message pack to reduce the size of the data you are storing there. And it's also used on a database called Treasured Data. It uses message pack at its default data for store information. Abro, on the other hand, is widely used in many databases and data-heavy services. BigQuery, Hadoop, Cloudera Impala, AWS, Athena. Those also support Abro for the data storage. It is optional though. You can select other formats, but Abro is going to be one of the main data types that it supports. For networking, and here in networking we are talking about RPC. We are talking about RPC, specifically for microservices. So message pack is supported by a protocol called zero RPC, which is not too popular. But protocol buffers is the one that has pretty much this niche home. Anybody has used gRPC here or know what gRPC is? Awesome. So gRPC is the RPC implementation of Google, widely used specifically in the Go ecosystem. Protocol buffers is the main type that we are going to be using for gRPC microservices. Abro, as I mentioned, has its own RPC implementation, depending where you are working. If it is with Node.js, you are just using Abro on top of a network server, or if you are in the Java ecosystem, you might be using Camel. Depending on where are you using Abro, there are like certain services that can give you this RPC support. And messaging or message passing, here we are talking about RabbitMQ, Kafka. So both protocol buffers and Abro are widely supported in Apache Kafka. So Apache Kafka used for sending a lot of information on the network. It is an event-driven system, and we will need to have data that is small and that can encode and decode fast to have higher throughput. If I want to scale my system, if I want to have like a lot of messages going on a network, I will need to use these data types, these instead of sending like big payloads with JSON or just a string. Kafka supports its own schema registry to keep a repository of schemas and version evolution. So it has a specific API where you are going to upload your schemas, and Kafka automatically is going to take care of the encoding and decoding depending on the schema you have associated with a topic in Kafka. So if you are going to be working with Apache Kafka or Red Panda, I will recommend you to learn either protocol buffers or Avro. We at Salesforce uses both protocol buffers like the gRPC layer and Avro for our PubSub API. We have a PubSub API for event-driven programming. Our platform can submit many events to communicate internally and externally with other systems. And recently we launched support for gRPC, so you can connect directly to a gRPC system and get the data. But we are using Avro for the event payload. So the payload that we are submitting, we encode that one in Avro, and we send that package in Avro on top of gRPC. So we are doing a double conversion in there, but it has given us a lot of flexibility and performance as well. Now let's take a look at numbers, because I talk too much, and if you don't see the numbers, you don't believe me. I have 3 minutes, so gladly I already ran the numbers here, but I can do it again. So the code is going to be available on my GitHub, so let's take a look at message pack. Normally my JSON payload is 279 bytes. The result with message pack is going to be 217. I have a gain, depending on how big the data is, I'm going to have a bigger gain, and it's going to be good for certain APIs. But if I take a look at protocol buffers, I have way less than even half of the size of that data. So if I'm using this on a mobile application where data is expensive, or if I need to reduce that payload for throughput purposes, now I have gains here. But if I go and take a look at Avro, it's way smaller than the other ones. So Avro is going to be more efficient if we are talking about size, about the size of the payload. If we take a look at the result, they're just going to be binary files. If I want to read the protocol buffer, the message pack file, it's binary. You can see the properties in there, but I barely understand what's going on. Or if I read the Avro one, I just get some data, not all of the data, because now the numbers or booleans are going to be encoded as bytes. So I will need to use hexadecimal reader to maybe understand a little bit more what's going on in there. So now that's going to be the message representation. It's going to be way smaller than the usual. But I have some benchmark as well. So here we have a schema that represents a coupon using I think this is the Stripe API. So binary encoding, benchmarks, schema, coupon. So yeah, let's read it on protobufels. So I have a kind of like a big schema, and this benchmark is generating this data randomly using both JSON and JSON string, depending on the implementation we are using in Node.js and JavaScript, message pack, protocol buffers, and Avro. And here we are measuring the number of operations by second, both in the decoding and the encoding operations. So here we can see, for example, that protocol buffers is going to be faster while decoding information, while reading information. But Avro here is going to be faster while encoding. So I have thousands of operations by second while I'm trying to encode information. And you can also compare that JSON is going to be faster than message pack. So message pack, even though it's giving us like a smaller size, it is not that fast. I have another couple of examples here. This is using message pack in Redis. So if I execute this, I am storing the data in Redis using message pack, and I'm using also the Redis pops up to submit data using message pack. So if I read the keys, I can get the character, and if you see the character, now the character is not a JSON, but it is in binary format. So I'm going to be storing less size or less data in my specific Redis service. Or I can also subscribe, read what's going on that channel, and I'm getting also binary data coming. Here you are seeing the data decoded as JSON, but here you are seeing the data encoded as message pack. Same with an API. You can have an API that, let's say, encode information as JSON. This is the JSON we know. Or you can also pass the accept header, so give me the binary data that I want in message pack, and now it is giving me that data, depending on how you configure the API, and the code is going to be available for you to take a look in using binary protocols. I think there is message pack, Fastify. I'm using an OJS server for this. You can pass a serializer that takes care of that message pack type and perform the encoding and decoding. And last but not least, I have the gRPC both on gRPC and Avro. And in the benchmark, I already run this. I have two operations. This is for a tabletop. One is to create a character, so it's going to create one of those Dungeons and Dragons character randomly using random data. And the other one is with a method to roll a dice. Give me a random number between 1 and 20. I implemented this using a gRPC, creating the protocol, and I'm running the benchmarks. For the character, we can see that Avro can run 2,700 operations by second, compared to gRPC, which only run 562. And for rolling the dice, I have like 3,200 compared to 983. So Avro, the RPC implementation, specifically is going to be way faster than gRPC. So this is why Avro became my favorite one. And that's the one I use while working with Kafka, and that's the one I use while working with gRPC microservices. Coming back to the presentation to say goodbye, last thoughts. This is optimal for internal integrations and control microservices. This is not generally for the public or a public API. For public APIs, REST and JSON are amazing. Everybody can read and write JSON. But for internal integrations, if you have like multiple systems interconnected, you might want to reconsider these if you want to increase the throughput and scalability of your application. Perfect when throughput, bandwidth, or performance are key. And also if for some reason you need to send smaller payloads, otherwise you are going to be paying more bandwidth. This is key as well. And also you need to take into account that you will need to keep backwards and forward compatibility through the schema evolution. This means adding or removing fields to the schemas. Data changes, the data evolves, so you will need to be careful with these things while using both protocol buffers and Avro. And thank you very much. Most of this information is on an amazing book called Designing Data Intensive Applications by Martin Klebman. If you like distributed systems, I will recommend you to take a look at that book. And that's my Twitter, that's my website.